Hello everyone, my name is Dr. Shabin. I am presenting the session 7 in the module Basic Processing Unit, 5th module in the subject Computer Organization. The table of contents are techniques of grouping of control signals, microprogram sequencing, microinstructions with next address fields. So, you might be thinking, what is grouping of control signals? Yes, of course, grouping is required in order to create a routine, micro routine. So, there are two types of grouping can be done, either vertical organization or horizontal organization. Vertical organization, it's highly encoded scheme that use compact codes, very small code to specify only a small number of control functions in each micro instruction are referred to as vertical organization. In horizontal organization, it uses the minimal encoded scheme in which many resources can be controlled with a single micro instruction. It is called as horizontal organization. The operating speed of vertical organization is slower, but when it compares to horizontal, it is it uses higher operating speed is required for horizontal organization. The formats are shorter formats and horizontal organization use longer formats. The ability of micro operations are limited. It also express and it can also be worked as parallel. How about here in the horizontal organization? The ability to express a high degree of parallelism can be achieved in the horizontal organization of grouping. Considerable encoding information of the control can be done. Little encoding of the information can be achieved in the horizontal organization. Now, let us see microprogram sequencing. The task of microprogram sequencing is done by a microprogram sequencer. So sequencer, if there is no sequencer, then it will be having the smoothful conduction, execution of the micro instruction will not take place one after another with the help of incrementer or other circuits. Two important factors must be considered while designing the microprogram sequencer. What is that? The one is size and other is address generation time. So the size of the micro instruction should be minimum so that the size of the control memory required to store the micro instruction is also occupied very less. This reduces the cost of control memory. When control memory is a house, it is a memory, read-only memory, which can store or accommodate the control words. So if the size is minimal, it can accommodate more instruction. If size is way too much, it can store very less number of instructions with less address generation time. As you know, if the number of micro instructions becomes more, the number of bits for the address will also be more. Say for example, initially you had a 8-bit phone number, nowadays 11-bit phone number. Why is it so? Because the number of customers using the phones are increased gradually, drastically I can say. Hence, the number of micro instructions becomes more, the address bits also become very, it also increases. It is directly proportional. During execution of a microprogram, the address of the next micro instruction to be executed has three sources determined by the instruction register, next sequential address and branch. Microprogram sequencing. The basic component of a microprogram control unit are control memory and the circuits that select control memory and the circuit that selects the next address. The address selection is the address selection part is called as microprogram sequencer. The address selection part is called as a micro. As I already told you, The address sequencing is also called as a sequencer. The purpose of a microprogram sequencer is to present an address to the control memory, an address to the control memory, so that the instruction may be read and executed. If this is not there, sequencing is not there, address sequencing, then there will not be any smoothful conduction execution of the microprogram. The block diagram of the microprogram sequencer as shown here, it contains control memory is included in the diagram to show the interaction between the sequencer and the memory attached to it. There are two multiplexers in the circuit. One is here, one is here. Mux 1 and Mux 2 multiplexer. The first multiplexer, Mux 1, selects an address from one of four sources and routes it to into the control address register. Sources, so what are the sources? 0, 1, 2, 3, 4 is to 1. And using the external map. External map is nothing but it gets the address from the external sources. The second multiplexer tests, it tests the value of the selected status bit. So it is basically conditional branch. Test the value of the selected status bit and result of the test is applied to what? Input logic. Input logic circuit. The test here, test is applied. Yes, here it this values and the result will be given to the input logic. The output of CR control address register, the output of the control address register is given to control memory, provides the address of the control memory. The content of CR control address register is incremented and applied to one of the multiplexer inputs. You can see it is applied to one of the multiplexer. Okay, here two inputs are given, one multiplexer, another it is given using the logic. The other three inputs to the multiplexer come from the address field of the present micro instruction. The other three input of multiplexer comes from the other three inputs are coming from SBR. Another is uh, from the AD address data register. Okay, so the address field of the present micro instruction from the out of the SBR subroutine register from the external source that maps the instruction. The CD condition field of the micro instruction selects one of the status bits. CD selects one of the status bits. Status bits in the second multiplexer. If the bit selected is equal to 1, the T variable is equal to 1. Otherwise, test variable is equal to 1, otherwise it equal to 0. The T value together with two bits from the BR field and goes to an input logic circuit. Input logic where the other two fields I0, I0 and I1. It goes to T field which is nothing but test field. Will go to the input logic. The input logic in particular sequencer will determine the type of operations that are available in the unit. Micro instruction with next address field. The drawback of previous organization which I discussed now, the micro instruction requires several branch micro instructions which perform no useful operation. There is no meaningful operation at all. Thus, they try to deviate from the deteriorate the operating speed of the computer. What is the solution then? The solution here is include an address field as part of every micro instruction to indicate the location of the next micro instruction to be fetched. So that means if it becomes a next address field is added into the micro instruction, then it will be easy for the fetching. Thus, every micro instruction becomes a branch micro instruction. This is how next address field should be added. The flexibility of this approach comes to an expense of additional bits because we are adding the address field, the number of bits in the instruction will become more. Advantage, what is the advantage? The separate branch micro instructions are virtually eliminated. That means you need not use the separate branch instruction. What is the disadvantage? Additional bits of the address field, around 1 to 6 bits will be using. There is no need for counter to keep track of sequential address. There is sequential address is not required. Hence, microprocessor is replaced with micro address register. And this is one of the drawback. The next address bits are fed through OR gate to the micro address register so that the address can be modified on the basis of data in the instruction register. External inputs and condition codes. These are the three things. Depends on that. OR gate can be functionality of OR gate can be evaluated. The decoding circuits generate the starting address of the given microroutine on the basis of opcode in the instruction register. Micro address register generates a starting address of the microroutine, a given microroutine on the basis of the opcode operation code. These are the references, and here is the end of the session 7. Thank you.